There are mysteries, things that we don't have a clear scientific explanation for, and we would like to figure out the nature of this object.
The room went silent the second the trajectory locked in. Not a pause, not confusion. Silence. The kind that signals something has gone very wrong. The orbital simulation finished rendering, and 3I Atlas did not wander through the solar system the way interstellar objects are supposed to. It cut in sharply, cleanly, almost surgically, slicing through the solar system's orbital plane as if it had been drawn there on purpose. This was the same flat disk where Earth, Mars, Jupiter, every major planet moves in near-perfect alignment. Interstellar space is vast and chaotic. Objects do not naturally thread this needle, yet 3I Atlas did. Scientists immediately assumed the model was broken. They ran it again, then again. Different teams, different software, different assumptions. The result refused to change. The path stayed razor clean, hugging the planetary plane with unsettling accuracy. This was not how debris behaves. This was not how random gravity slingshots look. Normally, interstellar objects arrive tilted, messy, unpredictable. This one arrived aligned, like it knew where the solar system kept its traffic lanes. Probability models were pulled up next, and that's when tension turned into alarm. The odds of a random interstellar object entering at this angle were brutal. Roughly 1 in 500. And that was being generous. Those numbers did not scream coincidence. They whispered something worse: selection, precision, a trajectory that looked less like chance and more like a solution to a problem. One researcher quietly pointed out that this alignment minimized detection delay and maximized planetary exposure time. No one laughed. No one argued. Desperation crept into the room as scientists hunted for an escape hatch, some overlooked gravitational nudge, some unseen stellar influence. None appeared. The math held. The path held. And with every failed correction, the original question collapsed. It was no longer what is 3I Atlas. That question felt almost naive now. The new question was sharper, heavier, and far more dangerous. Why did it come in like this? And why now? And just as that question settled in, another screen updated, showing something even harder to explain, something that would make the trajectory look like the least of their problems. It was visible when it should have been invisible. That was the first shock. A mid-tier ground telescope, nothing exotic, nothing designed for deep space surprises, picked up 3I Atlas at a distance where even large comets normally fade into noise. The detection was not borderline. It was clean, bright, impossible to ignore. Scientists stared at the data in disbelief because according to every known model, this object should not have been shining yet. Brightness at that range only comes from two things. Either the surface was reflecting light with extreme efficiency, or the object was far larger than anyone wanted to admit. When the first brightness models finished processing, the room went quiet again. If the light was coming from a solid body, the math forced a disturbing conclusion. The object's size was not comet scale, it was city scale. Comparable to Manhattan Island. That number did not fit inside any existing category of known interstellar visitors. Oumuamua had been small, odd, but survivable within theory. Borisov had followed familiar comet behavior. This was different. This was orders of magnitude off. No known interstellar population predicts objects this massive entering the inner solar system on human timescales. Models suggested such bodies should appear once every 10,000 years, if at all. Yet here it was, detected early, glowing, confidently, refusing to hide. Panic followed quietly. Astronomers rushed to construct a safer explanation, one that did not involve rewriting decades of astrophysics. The preferred solution became a thick coma. A vast cloud of gas and dust surrounding a much smaller core, artificially boosting brightness. On paper, it worked. In practice, it raised new problems. The coma required production rates that pushed known comet physics to its limit. Gas outflow would need to be extreme, sustained, and oddly uniform. Worse, early spectral data hinted that the composition of this coma did not behave like typical volatile-rich comets. The brightness stayed too stable, too controlled, too consistent for something actively boiling itself apart. If it was small, it was glowing too much. If it was large, it was glowing too early. Either explanation broke something fundamental. As more data streamed in, scientists realized the brightness was not fading the way distance alone would predict. It was holding, adjusting, almost compensating. That behavior had no comfortable explanation. Natural comets brighten chaotically. This object did not. And then came the most unsettling realization of all. If the size estimates were even partially correct, then 3I Atlas was not just anomalous, it was unprecedented. Larger than any known interstellar visitor. Detected sooner than expected, brighter than physics allowed. The question stopped being, what is making it shine? It became, what else have we misunderstood? Because if this brightness was hiding something larger, then the next phase of the mystery would not be about light at all. It would be about timing, probability, and why the universe seemed to deliver this object exactly when humanity had just begun to notice the dark, and the numbers were about to get much worse. The warning did not come from a telescope. It came from a spreadsheet. As probability models updated in real time, scientists watched expected timelines collapse. Based on everything known about interstellar debris, an object of 3I Atlas's suspected size should appear once every 10,000 years, not once a century, not once a lifetime, once across entire civilizations. Yet, here it was, arriving barely 8 years after humanity began serious, wide-field monitoring of interstellar space. That timing alone broke the math. 3 interstellar objects in such a short span was already uncomfortable. The third, being potentially orders of magnitude larger than the previous 2, pushed the situation beyond coincidence. Models that once felt stable now looked naive. Detection curves failed. Population estimates shattered. Either the universe had suddenly changed its behavior, or humanity had been catastrophically wrong about what was out there. Researchers searched for safer explanations. They whispered about selection bias, suggesting that better telescopes simply meant better luck. Others blamed detection thresholds, arguing that earlier objects were missed, but those arguments collapsed under scrutiny. Improved instruments could explain finding more objects. They could not explain finding something this large, this early, and this aligned. The mismatch was impossible to ignore. If 3I Atlas fit the models, then the previous interstellar visitors should have been smaller, rarer, and slower. Instead, the sequence was inverted. Each arrival seemed more extreme than the last. It was as if the universe was not easing humanity into awareness, but accelerating the confrontation. Not a gentle introduction, but a forceful intrusion. Inside closed meetings, one phrase began circulating quietly: schedule violation. The universe was not behaving randomly anymore. It was not tapping politely at the door of discovery. It was pounding, demanding attention, compressing millennia of expectation into a single decade. And no model, old or new, could explain why now had been chosen. As scientists prepared to rerun the simulations yet again, an even more disturbing question surfaced, one that statistics alone could not answer. If the timing was not random, What had triggered it? The sentence did not sound dramatic when it was written. It sounded mathematical, cold, measured. Yet the moment Avi Loeb placed the words on the page, the object may have been aimed. The room around the data seemed to tighten. This was not speculation wrapped in wonder. It was a conclusion drawn from alignment probabilities, orbital mechanics, and numbers that refused to behave. The sentence did not ask a question. It implied intent. And that implication was radioactive. Inside the peer review process, alarms went off without noise. Editors flagged the phrase immediately. Reviewers circled it, not because it was sloppy, but because it was precise. The math behind it was difficult to attack. The fear was not that the sentence was wrong. The fear was that it could not be easily proven wrong. Within days, Loeb was told the wording crossed an invisible line, too suggestive, too destabilizing, too dangerous for formal publication. The sentence was removed, but the numbers stayed. What followed was stranger than a public argument. Emails grew cautious. Conversations stopped mid-thought. Scientists who had reviewed the draft avoided discussing that single line as if repeating it might give it weight. Yet privately, the same question kept resurfacing. If the trajectory were random, why did it look so deliberate? No revision erased that discomfort. The paper moved forward, but something vital had been cut out. Loeb did not let it end there. Instead of retreating, he isolated the problem. He published a separate analysis focused entirely on trajectory behavior, no speculation, no storytelling, just probability and geometry. The numbers were laid bare. The odds remained brutal. Alignment within the planetary plane. Entry angle consistency, timing that brushed past coincidence and into improbability. The conclusion was softened in language, but not in substance. The implication survived. The reaction was immediate and violent in academic terms. Critics accused Loeb of courting attention, of bending statistics toward drama. Others warned that such framing could fuel public panic. But behind closed doors, a different response emerged. Several researchers admitted they had run the same calculations and quietly reached similar conclusions. They had simply chosen not to say it out loud. What unsettled them most was not the word aim. It was what came after. If the object's path was intentional, then its silence mattered. No signals, no flares, no obvious propulsion, just a clean pass, perfectly timed, already leaving. That behavior did not resemble exploration. It resembled delivery or observation, and the window to understand it was shrinking by the hour. As 3I Atlas slipped farther from Earth's reach, the forbidden sentence began echoing again, no longer buried in a paper, but alive in conversations, simulations, and late-night recalculations. The question was no longer whether the sentence belonged in print. The question was whether humanity had just ignored the most important warning it had ever almost published. And as the data streams thinned and the object faded into deep space, a more dangerous thought surfaced. What if the next one doesn't stay silent? The danger was not what 3I Atlas might be. The danger was how quickly science tried to decide what it had to be. On paper, the object still carried a safe label, natural comet. That classification appeared in databases, press briefings, and early summaries. But inside research rooms, the word felt thinner by the day. No known comet behaved like this. Natural comets follow patterns. They brighten gradually. They shed gas in predictable ways. Their paths wobble under gravity and radiation pressure. 3I Atlas refused every one of those expectations. Its brightness surged too early and too cleanly. Its apparent size forced models into uncomfortable extremes. Its timing, arriving just as detection systems reached maturity, felt statistically cruel. And its alignment through the planetary plane remained the hardest fact to bury. Each proposed explanation solved only one anomaly at a time. A dense dust coma explained brightness, but not alignment. An unusually large nucleus explained size, but not timing. Selection bias explained discovery, but not probability. Every solution created a new contradiction. Avi Loeb warned that this pattern was the danger signal science is trained not to ignore. When data refuses to converge, it is not noise. It is a message. Slowing down, he argued, was not surrender to speculation. It was discipline. History offered an uncomfortable precedent. Pulsars were once dismissed as instrumental errors. Continental drift was labeled impossible for decades. Ball lightning was treated as folklore. Anomalies, again and again, were forced into natural categories simply because no other box existed yet. The real fear was not extraterrestrial intelligence, it was intellectual reflex. Blind certainty has ended more scientific progress than imagination ever has. If even a fraction of 3I Atlas's anomalies were genuine and not artifacts, the implications escalated beyond comets. A deliberately engineered object would not glow, broadcast, or announce itself. It would pass briefly, silently, on a precise trajectory, leaving behind only data and doubt. And 3I Atlas was already doing exactly that. As the object continued its outbound path, one question began to replace all others, not what it was, but what kind of observation window humanity was about to lose. Because if this was not a natural wanderer, then the next phase would not be discovery. It would be realization. The danger is not coming. It is already leaving. 3I Atlas is accelerating away from the inner solar system, slipping back into the dark at a speed no human mission can chase. Every hour that passes closes the window for answers. Telescopes strain to collect final data as the object fades, knowing this may be the last clear look humanity ever gets. There will be no second pass, no retry. Whatever was missed now may be lost forever. Scientists are racing not against discovery, but against regret. No spacecraft was positioned to intercept it. No probe was waiting on standby. When 3I Atlas appeared, it arrived too fast, too cleanly, and too unexpectedly. Space agencies were caught unprepared. Retrofitting a mission would take years. The object will be gone in months. That mismatch alone has left researchers shaken. History may record this as a moment when humanity saw something unprecedented and watched it slip away. The most troubling part is what could not be tested. There was no sensor designed to distinguish chance from intent, no instrument capable of confirming whether subtle trajectory adjustments were passive or controlled. Scientists can measure brightness, velocity, and chemical signatures, but not purpose. If 3I Atlas carried structure, logic, or design beyond natural physics, current tools may never detect it. The object may have passed its closest point with its secret intact, and that uncertainty is now locked in place. If 3I Atlas was deliberate, if its path, timing, and behavior were chosen, then the event is already over. Whatever signal or reconnaissance it performed may be complete. No explosion, no announcement, just a silent pass-through and departure. That possibility forces an uncomfortable realization. Intelligence would not need to stay. It would only need to observe. But the alternative is no safer. If the object was natural, then the universe has just revealed something far more dangerous than expected. A class of interstellar objects far larger, brighter, and more precisely aligned than existing models predict. Objects that arrive without warning. Objects detected late. Objects capable of crossing planetary zones with unsettling accuracy. That alone would demand a rewrite of cosmic risk assessments. Either way, science is cornered. Astronomers now face a future filled with what-ifs. What if more are already on the way? What if detection systems are years behind the threat curve? What if 3I Atlas was not rare, but merely the first one noticed? The models are being rewritten in real time, but the answers are slower than the questions. And the most disturbing truth remains unresolved. Whatever 3I Atlas was, it did not drift blindly. It did not stumble into view. It arrived, passed through, and left, cleanly, quietly, and on schedule. The only question left is not what it was, but whether the next one will give us time to react.